All right, we're at chapter 18, acids and bases. So let's kind of get right to it. What the heck's an acid? What's a base? Back in the old days, they used to taste things to classify stuff. So you come across some unknown compound and just give it a taste. It'd be like the first thing you do. Like, what's this taste like? And these terms are actually rooted way back in the old times because they have certain tastes to them. Acids are sour and bases are bitter. All right. But there's all sorts of properties of acids and bases, so let's kind of go over all those. So, as I said, acids, they taste sour. You guys eat lots of acids. We all eat lots of acids. They're tasty as long as we're not eating strong acids. Actually, all of the acids we eat are weak acids. All right, they're not dangerous. They're not going to melt your face off or anything crazy. If you get a strong acid on you, it's going to burn. It's going to not feel so good. Acids, they turn litmus red. So litmus is an organic dye. It's either blue or red. If you put acid on red litmus, it obviously just stays red. But if you put it on blue litmus, it'll turn it red. It's the old litmus test. pH, we'll talk about pH later in this chapter, but acids have a pH less than 7. Acids react with metals to produce hydrogen, react with active metals to produce hydrogen. And they also eat carbonates, things like, limestone or chalk. They'll react with, and sodium bicarbonate, baking soda, that good stuff. And acidic solutions will conduct electric current. They are electrolytes. Now, base. If you get a base in your mouth, it's going to taste bitter. Bitter's a little bit different than sour. It hits your tongue in a different place. Can't really think of anything that most people would have eaten that I could describe as bitter, like tamarind. If you do any if you've ever made pad thai from scratch, tamarind is pretty bitter. If you get a strong base on your skin, it feels slippery. It's because it's dissolving your skin. It will turn red litmus to blue, so base goes blue. Acid goes red, as they said in that old chemistry show that I used to show my classes. The pH of a base is above 7, and these things will conduct electric current as well. All right, so all these things, we have things that make acids, things that make bases. In a way, they're opposites of each other. If you take an acid and mix it with a base, they neutralize each other. So all the properties of the acid are gone. All the properties of the base were gone. You get salt water when it's all left over. So the only property that's left over is it will conduct electric current. So acid plus base makes salt water. So start to just memorize that little tidbit. All right, naming acids, we actually did this a while back. So binary acids, right, 2 elements. So it's hydrogen plus something else. So HF, HCl, HBr, HI, H2S. There's a whole bunch of these things, but hydrofluoric acid, hydrochloric acid. Remember, these are named based on the anion. So if the anion ends in ide, IDE, right, it gets a hydro prefix and becomes an ic acid. So fluoride, hydrofluoric acid, chloride, hydrochloric acid, and so on. Cyanide, hydrocyanic acid. We also talked about the ternary acids, also known as the oxyacids, right? Because look at all those oxygens right there, right? So nitrate, NO3 minus, and nitric acid, HNO3. Sulfate is SO4 2 minus, H2SO4, sulfuric acid. So I ate something icky and it gave me an itis, right? Phosphoric acid, HTP4, and so on. So if the anion ends in ite, so if I had NO2 1 minus, that's nitrite, then HNO2 is nitrous acid, and then you had sulfurous acid, and so on. So what have you been spotting on all these things? So look at all these H, and well, there's that H. Here's a bunch of acids. You see something on all of them? It's kind of pointed out with a big pink arrow here and lit up here. All right, so the first definition of an acid was by Arrhenius, and he defined an acid as any electrolyte that would produce H plus ions in water. All right, so H plus, imagine, so hydrogen, a hydrogen atom minus an electron is H plus, but a hydrogen atom is only made up of a proton and an electron. So a lot of times we call H plus a proton. So we talk about protons a lot in this chapter. We're not really talking about nuclear chemistry or anything crazy like that. We're just talking about H plus. And speaking of H plus, when it is in water, it usually doesn't float around just by itself. It sticks onto a water molecule and creates what's called hydronium, H3O plus. This is a more accurate description of H plus in water. It's a hydrated proton, basically. So we have H3O plus. So, but you'll see these used almost interchangeably. It's easier to write a lot of our equations if we just use H plus. But if I want to be a little bit more accurate, I'll put H3O plus. I'll bring water into the mix and fiddle with that. All right, what else we got here? Ooh. So you can have a really acidic solution if you have a lot of hydronium in there. So lots of hydronium means that solution is very acidic. Little bit of hydronium, not very acidic. All right, we'll get into like a strong acid and weak acid. That's going to be a little bit later. I'll tell you now what it means, though. A strong acid dissociates 100%. So HCl is a very strong acid. Why? Because it dissociates 100%. If I put 1 mole of HCl into water, I get 1 mole of hydronium. I get 1 mole of chloride. All right, so it's a very strong acid. HF is a weak acid. When I put 1 mole of HF into water, I still have almost 1 mole of HF in the water. I get very little hydronium and very little fluoride floating around. That's why this is a weak acid. So bases are the opposite of acids, right? So what can you add to H plus to kind of neutralize things? And we know we get salt water when we add acid to base. So what can we add? What could we put with that? What goes with hydronium that's going to kind of knock it out? How about hydroxide, right? So hydronium plus hydroxide makes water. Cool. And the anion from the acid and the cation from the base, that's what makes the salt. So it's this is the stuff that's going on. So Arrhenius defined a base as any electrolyte that produces hydroxide ions when dissolved in water. The other phrasing I've heard of this is that they are anything that increases hydroxide concentration, or for an acid, anything that increases H plus ion concentration. So I've seen slightly different wordings of the Arrhenius definition from textbook to textbook. They're all pretty much the same. All right. So if I take sodium hydroxide, right? Sodium hydroxide, all sodium salts are very soluble. So you put that in, dissociates 100%. You get a bunch of sodium. You get a bunch of hydroxide. If I were to take my sodium hydroxide solution and then mix it with a hydrochloric acid solution, so HCl, so you have all this hydronium and chloride floating around in there. The hydronium and the hydroxide make water. The sodium and the chloride, they just stay floating around, right? Sodium chloride is a soluble ionic compound, so as long as it's in that water, it's going to be dissociated like this. So you get salt water. Pretty cool. All right, we're going to stop here, and then we'll get into some more definitions of acids and bases in the next lecture. See you in that one.